Okay, you can start now.
Hi everyone. So welcome to Edu for Space's first webinar for World Space Week. We're super excited to welcome Karin and her talk about non-technical space careers, especially her work on her analog space mission. And we already have a bunch of questions lined up from people who signed up and on our server, so we can't wait to ask you them at the end of your presentation. Take it away.
Thank you very much, Sveta. So today we're going to Mars. But first of all, I would like to introduce myself a bit so you understand where I'm coming from. I am originally a global project manager. I've been 25 years in the industry. I am a certified project management professional. I also work as a trainer and coach and university lecturer for various universities all over the world on the topics of project management, leadership skills, and intercultural competence. My connection with the space industry started some years ago. I've always been a space enthusiast since early childhood. But then there was not so much going on in space. The Apollo program ended and there was no replacement for that. And then some years ago, Elon Musk started talking about going to Mars. And I said, oh, I want to be a part of that. It's too exciting to be left out. And I thought, well, what can I do? Because I haven't... I'm not in a technical career. I have a background in IT and psychology and management. But I thought, well, astronauts, they also need intercultural training, and so does everybody who works in space. So I just picked up the phone and spoke to the Austrian Space Forum if they don't need an intercultural trainer, and they said, yeah, of course we do. And they invited me to get to know their culture by way of participating in an analog mission training. So I went to Innsbruck. I participated in the mission training, which is not for the analog astronauts, but for the people in mission control. And at the end of the training, they asked, well, don't you want to join us as a flight planner, which is basically project manager? And I said, yes, of course, I would like to. So here I am, flight planner for the Amade 20 analog Mars mission, which will take place next year in October, November. It was planned for this year, hence Amade 20, but the COVID situation forced us to postpone it for the safety of everyone involved. In addition to that, I have taken on some work as a project manager at a company called Borospace. They're a small Slovak startup company building suborbital rockets and developing sustainable rocket fuels. So again, I'm not a rocket scientist, but I can help in the project management of these endeavors. Yeah, so the Austrian Space Forum is a so-called citizen science institute. That means that almost anybody can just join and can help in some way. We have more than 220 members now. We were founded in 1998, so it's already pretty old. And some of the research we're doing in the Austrian Space Forum is, for example, development of hardware, the AUDA spacesuit simulators. So they're not the spacesuits that astronauts will actually take into space, but they help simulate wearing a spacesuit on Earth during the analog Mars missions, and also development and testing of Mars rovers, which I will go into a bit more detail in a while. In terms of research, planetary surface operations, like experiments in terms of geology, biology, etc. But we're also optimizing remote science support, like the Mission Control Center. We are testing the best way to set up the Mission Control Center. We are testing the best setup for the remote science support, etc. And of course, it all comes together in international Mars simulations, where we actually pretend to be on Mars and conduct experiments there. Yeah. Of course, the question that I get more often: why should we go to Mars? Don't we have enough problems on Earth? Well, first of all, we have to go to Mars because it's there. Humanity, the evolution of the human race has been very much driven by exploration. People had to leave their caves, their valleys, their surroundings to explore other regions since even before the Stone Age, since ever there were people. And even today, if there is a mountain, we have to climb it. If there is an ocean, we have to sail it. It's just in our human nature to explore and to move on, to push our boundaries. And we have Mars there, so we have to go. The second question I get asked frequently: well, don't we have enough problems on Earth? Well, that the fact that we go to Mars does not mean that we don't solve the problems on Earth anymore. We can do both. Yeah? We can solve problems here and on Moon and on Mars. And a lot of research findings can actually be transferred from space back to Earth. There's an interesting experiments going on the International Space Station, where they want to try and print organs or parts of organs, for example, heart valves. They can be printed in microgravity because the result is much better quality, because there is no gravity impact. So we actually have advantages from the science we do in space here on Earth. So the question is, it's not really valid. Why do we go to Mars if we have problems on Earth? We can do both, and we will do both. So the next question is, of course, what is an analog Mars mission? An analog Mars mission actually is we pretend to be on Mars or on Moon in an analog Moon mission by having a habitat somewhere in a zone that in some aspects is similar to Mars. And which regions and which location exactly is chosen always depends on the type of experiment. So if you want to do geological experiments, you look for an area that is geologically similar. If you want to explore how people could potentially live in lava tubes on Mars, then you want to go to a region where there are lava tubes on Earth, for example, in Hawaii or in Iceland. And in this mission, we pretend to be on Mars. That means we have a habitat where we have analog astronauts. So we simulate it as best as possible. So, for example, the astronauts cannot leave the Mars habitat without putting on a spacesuit, or in this case, a spacesuit simulator. and they are conducting experiments just like they would do on Mars. Yeah, they're testing different rovers, they're testing tools, they're testing procedures, etc. And I will show you some photos in a bit, so you have a better understanding. So maybe you can write in the chat which photo was taken on Mars, left or right? Yeah, it's difficult to say, yeah. So the left photo is actually taken on Mars. The right photo has been taken during the last mission, Amadei 18, which was taking place in Oman. So this is the desert of Oman. So you can see there is certain similarities, even down to the color of the soil between this desert and actually the surface of Mars. Yeah. So what we do is we study equipment behavior involving the simultaneous deployment of instrument and robotic vehicles with humans in the loop. So, for example, how feasible is it to operate a rover with a spacesuit and gloves on? Yeah, can you change a battery in the rover with these space gloves on? Especially in the Amadei 20, we will also have experiments for life detection. Yeah, so we are looking for, yeah, we collect geological samples and see if there is any traces of lives in terms of bacteria or certain chemical substances. Yeah. Also, we test orientation tools, like how can we best, because we haven't gotten Google Maps on Mars. Well, it is on Google. Mars is actually on Google Maps, but there is no roads, no habitats in there, so we would have to orientate ourselves in a different way. And then, of course, it's a marketing. We want to bring space exploration, the value of space exploration, to as many people as possible, especially to young people, to create interest in space exploration. And then, of course, we want to learn about how to manage a crewed mission to Mars when we deploy realistic mission support and with all the decision-making framework, with the communication lines and the hierarchical structures. So I think the fact that we don't have a rocket to go to Mars yet is the smallest problem we have. There's still a lot of bigger problems to solve before we can really live and work on Mars. Yeah, this is, for example, a spacesuit simulator. It weighs 50 kilos. The one that is to simulate the weight that we would experience on Mars, because Mars has about 1/3 of the gravity of Earth. So the real spacesuit that astronauts will wear on Mars will actually weigh 150 kilos. But to simulate the same restrictions and the same, exhaustion that you have when working and walking in a suit, that should be the same relative weight that we experience on Mars. So there is a lot of communication interfaces built in. It's advanced human-machine interface. and the outer layers optimized for planetary protection. Yeah, so it's to an extent it's shielding from radiation, etc. And it's made for 48 hours field operation. It has also broadband telemetry, so for example, doctors can gather the biometric data from the analog astronauts, like the heartbeat or their body temperature, so that nobody gets into any danger. And even for that, we need textile designers. Again, it's not all rocket science. We need IT people for the communication part, etc. Yeah, so a bit about the work I'm doing. I'm a flight planner. And what does a flight planner do? As I said, I am mainly a project manager. So I am currently responsible for 3 experiments in the Amadee 20 mission. There is 2 technical experiments and 1 psychological experiment. And as a flight planner, my responsibility starts at gathering all the information for each experiment. Yeah, how big is a rover? How heavy it is? How is it packed? Does it have batteries? How many batteries does it have? Which type of batteries does it have? How long will the batteries last? Who is going to change the batteries? All these things in very, very great detail. This is really the first step to get the full understanding and description of the experiment, of the hardware, if there is any, and of some procedures. Then, of course, what do you want to do? If you want to test a rover, how are you going to test it? How many hours? Is it okay if it's windy while you're doing the test? Yeah, do you do it the test once, or do you do it like 3 times every day? And how long a distance do you drive the rover? And all these kind of things. And that information is then entered into a flight plan. And the flight plan says, okay, astronaut A on Tuesday the 7th has to pick up the rover, has to load the battery, and then has to drive it for 700 meters, and has to then drive it back, and then has to recharge the battery again. So we plan all the to-dos for the analog astronauts, because that's the most expensive part of the mission. It's astronaut working time. So everything has to be planned down to, I would not say down to a minute, but down to 5 minutes, 10 minutes slots, so that everybody knows exactly what they have to do, when and where, and who is going to do it. The mission architecture. If you look at the left side, the red, there are the different experiments which will be carried out in and around the habitat. For the Amadee 20, the habitat is going to be in Israel, in the Negev desert. So there will be the habitat, and 6 analog astronauts will live there for a month, and they will conduct all the experiments. There is, of course, more than 3 experiments, but it would just crowd the slide. We have also this time a simulation of the 10 minutes communication delay, because that's the average real communication delay with Mars, because Mars is so far away. Even with the speed of light, it takes 10 minutes to get the signal to Mars, and another 10 minutes to get it back. Here on Earth, we are simulating this with a delay that is on the communication server. So this, of course, means that if you ask a question to the analog astronaut and they answer, it's a minimum of 20 minutes that you have to wait to get your answer. And even that causes some problems, because you cannot have the communication directly like we have now. So yeah, and I will be in the Mission Support Center in the blue building on the right, and will be responsible for my three experiments, the three experiments that I have been allocated to as a flight planner. So there is, of course, there are other non-technical people involved in this. There is, for example, there are medical doctors, there are media specialists, there are social media specialists, there are communication specialists, there are psychologists. So really only the astronauts in the field are doing most of the technical work. The other work is relatively non-technical and can be done after some training by almost anybody, I would say. Yeah. The Austrian Space Forum has so far conducted 12 Mars simulation. For example, on the bottom right, you see it's a Dachstein cave that's in Austria in the mountains. One other mission was in the Sahara Desert in Northern Africa. The last one in 2018 was in Oman in the desert. So as I said, depending on the nature of the experiments, we are looking for suitable locations that where we can actually make the research we are supposed to do. Yeah, here is again a comparison. The upper picture is Oman with two analog astronauts. This is what it looks like when they go out of their habitats and they go to work in the desert / on Mars. And below is actually a picture of Mars, and you can see it looks very, very similar. This is the habitat in Oman, the Kepler station, where the analog astronauts were living. It looks pretty at the sunset and sunrise. Here you see another two analog astronauts doing some geological experiments, and they use quad bikes to get around, because of course it's very hot in the desert and they sometimes have to cover long distances. So you might remember the last Apollo missions on the moon, where they had these kind of moon cars to get around. So in this case, for the simulation, we use quads for the same purpose. Yeah. Here you can see another two astronauts working with a small rover in an experiment. Just some. These are actually the three experiments that I have been allocated to. The AMAZE, Autonomous Mars Analog Zone Exploration. That's actually a drone, a small helicopter. That's even in collaboration with NASA Jet Propulsion Laboratory. Then there is another rover that I find very interesting from the concept. It's called Tumbleweed. You see the photo on the page. And this one is entirely driven by wind. That means that it can cover very, very large distances, but you can't steer it. It just goes where the wind blows it. But it's again, it's a very interesting approach to cover long distances. Then my third experiment is a psychological experiment. It's movement, space, and group health (MSG). Where we are analyzing the group health during the mission, and that's a research group in Israel. So I'm cooperating with the Israelis very closely on that. These are just some examples. Mission Support Center we have in Innsbruck, Austria, where we have flight planning, ground support. Ground support are people who are just responsible for the logistics, that we get everything we need. We have, of course, IT people. We have data managers, because we're collecting a lot of data during the experiments, and they need to be processed, they need to be stored in a safe place, they need to be transferred, etc. And also the remote science support. Plus we have external and internal mission control teams. So we will, after the next Mars mission, analog Mars mission, we expect to publish more research papers, like the Austrian Space Forum has done for previous space simulation missions. I hope this was of some interest to you. If you want to know more about the Austrian Space Forum, there is the website. If you want to know more about the Amadi 20 specific mission, there is the website. And if you have questions just for me, other than now, immediately, feel free to connect on LinkedIn or just send me an email. Because the topic is really non-technical space jobs, there is basically space companies and space exploration missions. They need pretty much the same people that other non-space companies need. Companies like SpaceX, they will need warehouse workers, they will need truck drivers, they will need finance managers, they will need cleaners for their building. They need human resource people. They need IT people, they need data analysts, they need project managers. I don't know, if I was a cleaning lady, I would rather clean the SpaceX offices than the local supermarket. It's just, it has this cool factor. So I can only encourage anyone and everyone to actually, even when you don't have the technical background, look around you, see what options there are in space. The astronauts, they need photography trainers. They need language trainers, they need intercultural trainers like me. So there is so many options. It's just I can only advise, just go and ask. And if you're not in the technical field, then just find something that suits you in the non-technical field in the space company. Okay. I can see there is already one question from Nuria. Any research on making the spacesuits lighter while maintaining the quality? Yes, there is a lot of research going on. We are not very happy with the weight, but we are. It's the best we can do at the moment. There are two factors. There is the weight of the spacesuit, and there is the time to put on a spacesuit. Even these spacesuit simulators, yeah, they can easily take up to 3 hours to just put on, because there's so many different layers and everything has to be airtight and all the cables have to be connected. And so there are a lot of efforts going on to make them lighter, to make them less bulky, and to make them easier to actually put on and also take off. Even taking off can take up to 1.5 hours for a spacesuit. It's not just you open a zipper and you just take it off like you take off a jacket or a sweater. It's quite complicated. So yes, there is a lot of people working on it, and there has been progress, and there will be more progress, and we need more progress before we go to Mars. The spacesuit is basically, you can compare it. It's a personal spaceship. When you, as an astronaut, are in Mars or on a spacewalk in outer space, this is your personal spacesuit. So it has to fulfill a lot of functions. Yeah, it has to protect you from radiation. It has to keep you warm or cold depending on where you are. Normally both at the same time, because you turn around once and you are at a different angle in the sun, and instead of having 200 degrees minus, you have 300 degrees plus. So there is so many parameters that the spacesuit and the material has to fulfill that it's not an easy task. And as I said before, the fact that we don't yet have a rocket to go to Mars is one of the smallest problems we have in Mars exploration. Thank you for the great question, Noria. Yeah.
Another question we got from beforehand is, how should an aspiring analog astronaut prepare themselves for a mission?
Oh. So, of course, they have to be very healthy. They have to be very fit, like sporty. So, both in terms of stamina, so they have to be able to work very hard for a long time. But they also have to, just the spacesuit weighs 50 kilos, so they have to be very strong, so they need to train their muscles. And also for physiological things, they have to prepare psychologically, of course. They have to be psychologically very healthy. They have to have coping mechanisms. But they get these trainings and tests. Of course, they're selected for being an astronaut, and they need to go through a lot of tests. We don't want to select astronauts that will then get either physically or mentally ill during the mission. And then, of course, you need to have a special knowledge that is needed on a mission. And that does not necessarily have to be engineering. On the contrary, we need biologists, we need medical doctors, we need geologists, we need psychologists, we need, in the future, when we want to live on Mars, we need architects, we need builders who can actually build a house, we need IT people. If you want to go really to Mars with, let's say, 100 people, you will need cooks, you will need cleaning personnel, you will need janitors, you will need all the hairdressers, whatever. So if you want to be an analog astronaut, you should look at what the current missions are researching, and then see if you have the specific knowledge. If you have, for example, studied geology or biology. So it doesn't have to be astrobiology. You can also just get selected with kind of normal biology. But that is just for the analog astronauts. But for the mission team, we need all kinds of different people. And for as I said, like textile designers for the spacesuits and things like that. Yeah.
Another question we got is, how long does an analog mission last?
So this specific one, the Amade 20, is planned for 1 month. Usually they last between 1 week and 1 month. But there have been some missions that lasted for a full year. So of course, the longer the mission lasts, the more realistic it is, because if talking about Mars, to the moon we can go there and spend a couple of hours and come back, and the whole thing going there, doing some science and coming back takes 2 weeks. But if we are talking about going to Mars, the minimum duration of a trip to Mars and back is 18 months. So the longer the simulation lasts, the more realistic it is. But of course we have constraints. There is of course financial constraints to actually finance the simulation. A lot of the analog astronauts, they are not analog astronauts by profession, but they do this as a kind of hobby almost. But it's not a hobby because they're really experts. They do this as volunteers, so they don't get paid, and it's, for many people, it's obviously very difficult to just take a year or a year and a half out of their paid jobs and not get paid and work on the Mars mission. Not everybody has the means to do that.
And finally, our last question is, what was the favorite mission you worked on?
Well, since this is my first mission, this is also my favorite mission so far. Yeah.
Well, that's all the questions we have received through the chat and beforehand. Thank you so much for your time. Really, really do appreciate you kicking off World Space Week and having you as a presenter.
You're very welcome, and it's been a pleasure sharing this with you. And if you have any questions after sleeping it over, yes, Nuria has another question, please. Go ahead.
Hi, Karin. Hi, everyone. So I apologize for the background noise, but I just had a question because you said you were the project manager for the analog mission, and I just wanted to know your take on doing analog missions virtually, especially considering now this time with the COVID and a lot of things are happening virtually, and in some cases you'd find that there are some maybe projects involving virtual analog missions. I don't know, maybe do you have a comment about that? And maybe if someone wanted maybe to organize this, maybe what would they have in mind?
Yes, again, another interesting question. Thank you, Nuria. So it depends very much on what you want to achieve with the mission. If you want to test rovers, it's not very well possible remotely, because you have to go somewhere. You have to be in the terrain. You have to go to a mountain slope and check if the rover can go up and down without tumbling over. In terms of my work, so I'm a flight planner for the Amade 20 mission. For the Austrian Space Forum. Austrian Space Forum is located in Innsbruck. I have been doing this for 1.5 years. I've been in Innsbruck once. So 98% of what I'm doing is actually remote. But I'm the flight planner. I do planning tasks. I don't take the rover into my hands and put it out and run it. Yeah. Even it's if for example, if you want to do psychological experiments, you could run certain experiments virtually. For example, I can isolate myself in my home without going out for half a year or so. But you can't virtually simulate a group being together in a very small space, because you can't simulate the small space virtually. So there could be some very specific experiments that could be simulated online, but not very many. But a lot of the work that is involved in the analog missions can be done online, like I'm doing. Also, I mean, the project manager for Borospace, the rocket company, it's basically online. Yeah? I communicate with the rocket engineers, and they build the rocket. I do the paperwork, I make calls, I make appointments, I try to sell the rockets. Maybe through virtual reality or something. Yeah, it's I haven't heard anything about anybody developing a virtual reality software for that. But maybe there is your market niche where you can where you can do some programming or get someone to program it and. So we have the feeling of being on Mars, but together as a group. However, this would actually require you to have to actually wear the virtual reality glasses, or be in the virtual reality room 24/7. Maybe you can take it off when you sleep, but other than that, you will not have the same feeling of being together. So it's a very good idea. And again, it depends really on what you want to do. Even if you have a virtual reality glasses on, you can still not test the rover, because the rover is a physical thing. Yeah. Or the drone, you have to really fly it, and you can't fly it in your living room. It's you don't have the conditions for that. But I think it's actually, we will see more of these virtual reality simulations in the future, but we're not there right now. So.
Awesome. Well, for real this time, I think that was all of our questions. Sorry for cutting us off a little earlier before. Those questions were awesome, and thanks again for everything from our other webinar that you did with us to this. You've helped us out a lot, and we really appreciate it. So thank you.
You're very, very welcome. And I hope to see you again soon, and good luck with all your endeavors and with your education program. I think it's really a very good idea, and it's something that we also need. So I hope you're enjoying the rest of the Space Week, and we see each other again.